So let's look at another example involving proofs. Now I want you to fill in the blanks in the proof of the following theorem. So this will match up with some homework questions you have. It'll give you a proof and ask you to fill in the blanks. So for all integers r and s, if r is even and s is odd, then 3r plus 2s is even. All right, so let's look at the proof here. So the proof is going to start out, suppose r and s are any integers such that r is even and s is odd. Okay, and then it's going to say by blank r equals 2m and s equals 2n plus 1 for some integers m and n. So let's go ahead and look and see if we can fill in this blank. So if we look back here, we're told that r is even and we're writing r as 2 times an integer. Well, we're using the definition of even to do that. If I look here, I'm told s is odd and I write s as 2 times a number plus 1. I'm using the definition of odd. So what goes in this blank is by definition of even and odd. Okay, so I filled in those blanks. I'm told the next part of the proof says then 3r plus 2s equals 3 times 2m plus 2 times 2n plus 1. So here you're going to justify each line of this equation. So let me go ahead and fill in the rest. 6m plus 4n plus 2. This is by distribution. That wasn't a blank, so I should just leave that not underlined. By distribution. And this is 2 times 3m plus 2n plus 1 by factoring out 2. So now let's fill in this blank. What did they do? They plugged in the equation for r and s, so they substituted. So this would be by substitution. Okay. Now let's keep going with the proof. So let t be 3m plus 2n plus 1. T is an integer because m, n, 1, 2, and 3 are integers, and because blank. Hence, 2t, where t is any integer. Let me just go ahead, since we're almost at the end, and just finish out the proof. And so by blank, 3r plus 2s is even. And then the end of the proof has a box in it. Okay, so let's fill in this first blank. T is an integer. Well, T is made up of these numbers, M, N, 1, 2, and 3. They're all integers, but then if I look at T, there are two operations going on. There's addition and there's multiplication going on. So it's because when I take products and sums of integers, I get an integer. Remember, integers are whole numbers. When I multiply and add whole numbers together, they stay whole numbers. So then I wrote 3r plus 2s equals 2 times t, where t is an integer. So by blank, 3r plus 2s is even. Well, if I write something as 2 times t, that's even, and that comes from the definition of even. So I would insert in here, so by definition of even, 3r plus 2s is even. So we filled in those blanks with our justification for those steps.